Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. Every statistical analysis begins with one assumption so fundamental we often forget to mention it. The sample we observe is representative of the population we want to study. Okay. But what happens if this assumption isn't true? What if people or firms, schools, countries that we observe are systematically different from those that we don't observe? Now, this seemingly simple issue can completely change the conclusions we draw from our data, and it's more common than most people realize. And the problem, it's called non-random sampling. So if we have this box in here, and we assume this is our population. So these are all of the observations in our population. Okay. And let's say we randomly pick one subset in here. Okay. Now, in most studies, we can't observe everyone. We collect information from a sample and use it to learn about the population. Now, this only works if the sample is representative. So this group right here that I randomly picked together should be representative of the entire population. And if it isn't, everything we estimate may be wrong. Not because of bad econometrics, but because of bad data. Under random sampling, every individual has the same probability of being included. So the sample should resemble the population, not perfectly, but on average. Okay, so on average. This is the ideal and what most econometric theory assumes as well. So the question is, what happens when it fails? Now, randomness doesn't mean the sample is small or noisy. It just means the selection process is unrelated to the variables we're studying. So a perfectly random sample of 100 people is more reliable than a biased sample of 10,000, okay? Think about of wanting to estimate the average height of university students. And the population contains clearly tall students, short students, and everyone in between. Now, suppose that we collect data only from the university basketball team. Does the sample represent the university? Clearly not. The estimated average height would be too large. And notice what hasn't gone wrong in here. OLS will be fine. The calculations will still be able to be done by whatever software you're using. The problem lies entirely in who entered the data set. And this is a crucial point because non-random sampling is not an estimation problem. Okay, so non-random sampling is not an estimation problem. Okay, it's a data problem. No statistical technique can fix a sample that systematically excludes part of the population. A second example would be, let's say, luxury shopping centers. We want to estimate average household income, but we collect data only from people visiting a luxury shopping center. Would you obtain a representative estimate in this case? No, we'd dramatically overestimate average income. The sample itself is the problem. So in both examples, certain individuals were far more likely to appear in the sample than others. And that's non-random sampling. Now, keep in mind, the process usually goes from population. We've got a selection process and ultimately an observed sample. Okay. There is always a mechanism that determines who we observe and who we never see. Under random sampling, the mechanism is neutral, unrelated to what we're studying. Under non-random sampling, the mechanism is selective, and that selectivity is what distorts our estimates. So the key question is always, is the selection process related to the variables in our model or not? So is this selection process random or not? Okay. Now, why does this matter for econometrics? If the selection process is related to the variables we're studying, our sample no longer represents the population, which means estimates based on that sample will not be able to generalize beyond the observed data. Okay. And keep in mind, the regression will not mathematically be wrong. It's just that econometrics is not broken, but the question we're answering now has changed, because instead of saying what is the effect of X on Y in the population, you are asking or answering what is the effect of X on Y among the selected observations. So these can be very different questions. In economics related fields, keep in mind, there are always examples about what could go wrong and why the question of who is missing is so important. Think about labor economics, studying wages using only employed individuals. Who is missing? Well, people who are unemployed, and unemployment is often related to wages. In finance, when you've got survivorship bias, you're studying investment fund performance using only funds that still exist. So who is missing? Funds that closed, typically the worst performers. Or health economics, you're estimating recovery rates using only patients who return for follow-up visits. Who is missing? In this case, those who recovered quickly and didn't need to return, or those too ill to return. So in every case, the missing observations are not random. They are systematically different from those that we observe. And that systematic difference is exactly what creates the problem. Okay. Now, keep in mind, there could be different selection mechanisms. So as we mentioned here, this selection process is very important. We have to check whether it's random or not. In the case where you have a selection process that is not random, it could be that you have a sample selection bias. Okay. Sample selection bias. It could be that you've got what is called truncation. It could be that you've got censoring or other types, really, of selection mechanisms. Non-random sampling is sort of like an umbrella term. So different selection mechanism will create different econometric problems and require different solutions. And throughout this little mini arc, we'll study the most important forms and learn how economists deal with which one. Now, common misconceptions is important to distinguish non-random sampling from having a small sample, okay? So non-random sampling versus having a small sample. A small sample can still be representative if it was selected randomly. Okay. A very large sample can be highly misleading if it is systematically excluding parts of the population. More data does not fix a biased sample, okay? So 10 million observations from a luxury shopping center still cannot tell you the average income of the population. And this will be one of the most important messages that you should be getting out of this mini arc. So scale does not compensate for selectivity, okay? Non-random sampling occurs when the observations we analyze are systematically different from the population we want to study, making our estimates answer a different question than the one that we intended. We've now introduced the broad problem, so our sample may not represent the population and more data doesn't fix it, but our non-random sampling can arise in many different ways, each with its own consequences and solutions. In the next video, we'll build a taxonomy of the most common forms, so stay tuned and I'll see you then.